When you picture a modern chemistry lab, you imagine a space exactly like this: colorful liquids, heat-resistant glassware, and a computer tracking the data. Imagine taking away the electricity. Remove the sensors, unplug the circuits, and pull out the monitors. If we strip a laboratory down to its absolute bare minimum, what are we left with? The laboratory's true utility persists even without technology: the systematic execution of controlled experiments. For centuries, scholars treated the physical world as a puzzle to be solved in their heads. A philosopher might spend years debating how a specific metal reacts to heat, without ever actually placing that metal in a fire to see if their hypothesis was correct. Over 1,200 years ago, a visionary scholar named Jabir ibn Hayyan recognized that these unverified assumptions were a dead end. Human understanding of the physical world was essentially stalled, waiting for someone to construct a dedicated space to physically interrogate matter. Jabir operated under a strict mandate: if you had an idea about a substance, you had to physically test it. He began systematically exposing different materials to extreme heat, moisture, and air, carefully watching how they reacted under stress. Jabir pursued the systematic isolation of pure elements, breaking raw materials down into their constituent parts through repeatable chemical actions. To do this, he utilized formal processes. By dissolving and carefully cooling a solution, he could force impurities out, a process called crystallization, leaving behind perfect needle-like structures. He relied on filtration, passing liquids through porous barriers to trap solid particles and extract clear fluids.
And he employed sublimation, heating a solid material until it vaporized, then catching the condensed gas, to completely bypass the liquid phase. These specific techniques gave scholars their very first reliable toolset. They could finally separate materials and accurately study their actual properties. Jabir realized that because these physical tests were so sensitive, a slight laboratory mistake could change the result entirely. If the fire burned just a few degrees too hot, the reaction would fail. If an ingredient's volume was off by a fraction of an ounce, a mixture might violently expand instead of settling into a quiet fizz. If a researcher carelessly rushed the exact same steps, they'd get totally different, unreliable data every single time. Because these tests were so fragile, Jabir enforced a new operational law in the lab: absolute precision. Physical measurements could no longer be approximate. Every gram of a substance had to be weighed and carefully considered before any mixing began. Observations were meticulously written down, allowing the exact same experiment to be run again so the results could be directly compared. This heavy emphasis on recording and standardizing was a massive departure from the philosophical guessing games of previous centuries. Earnest, this rigorous system made the laboratory an engine where verifiable truth was actively produced, rather than passively debated. Over the next several hundred years, these foundational practices matured, turning the early iterations of alchemy into a highly systematic form of chemical investigation. That evolution provided the foundation for modern chemistry, shaping the exact cylinders and clear glass beakers we still use to manipulate matter. And it all connects back to the core philosophy that unites Jabir's ancient workshop with today's multi-million-dollar research facilities. You do not simply believe an idea, you test it. That 1,200-year-old mandate to interrogate reality is what ultimately turned the laboratory into one of the most powerful tools in all of science.